On this worksheet, we're going to practice calculating concentration using all different kinds of concentration units. We have been given information about the solute that is dissolved in a solvent, the density of the solvent, and the density of the overall solution. We're going to use all of that information to calculate the concentration of this solution in a variety of different units, starting with the mass percent of the solution. Mass percent is calculated by taking the mass of the solute. KOH is our solute, the thing that we have the smallest amount of, the mass of KOH divided by the total mass of the solution. So the total grams of the solution. And then to make it a percent, we're going to multiply by 100. We know the mass of the KOH, 7.837 grams. The total mass of the solution is the combined mass of the KOH and the CH3OH. We don't know the mass of the CH3OH. We know its volume, but not its mass. We're going to use the density of that solution to figure out what its volume is. I'm going to just do that calculation right here. If we have 558.3 milliliters of this solution or this solvent, we want to multiply by a conversion factor that puts milliliters on the bottom, grams on the top. The conversion factor is the density, 0.7918 grams in every 1 milliliter. This is going to give us the mass of the CH3OH, 558.3 times 0.7918, a mass of 442.1, we'll say, grams of CH3OH. So the total mass of the solution is the mass of the KOH, 7.837 grams, plus the mass of the CH3OH, 442.1 grams. And we want to multiply the whole thing by 100, 7.837 divided by all of that times 100, 1.7%. The second and third problem are asking us to calculate the mole fraction of each one of the components. The mole fraction of the KOH is going to be the moles of the KOH divided by the total moles of the solution. So we are going to need to figure out the number of moles of the KOH. I'm going to do that calculation up here. 7.837 grams of KOH. We need the molecular weight of KOH. To do this conversion factor, 1 mole of KOH is about 56 grams. So we have 7.837 divided by 56. We have 0.14 moles of KOH. We're going to put that right here, 0.14 moles. The total number of moles of solution is going to be the moles of the KOH plus the moles of the CH3OH. So we need to figure that out as well. To figure out the moles of the CH3OH, we're going to use its mass. We've already got that part calculated, and we're going to convert that into moles. 1 mole of CH3OH divided by its molecular weight, which is about 32 grams. And that is going to be 442.1 divided by 32. 13.8 moles. So down here, the total number of moles is 0.14 plus 13.8. And the mole fraction of the KOH is 0.01. And this is left in decimal form, not converted into a percent. The mole fraction of the CH3OH is going to be the moles of the CH3OH divided by the total number of moles. The moles of the CH3OH we calculated to be 13.8. The total moles are the 0.14 plus the 13.8. And this should work out to be like 0.99. Thankfully it does. Remember that the sum of all the mole fractions must add up to 1. So it is possible when you're asked to calculate the second mole fraction, it would be okay for us to just do 1 minus the mole fraction of KOH. But it's kind of good to just go through this separate calculation, and that's a way of, verifying that your original mole fraction was accurate. What is the molality of the solution? The molality of the solution is going to be the moles of the solute, KOH, divided by the mass of the solvent in units of kilograms. And the solvent is the CH3OH. Our moles of KOH, let's scroll back up and get that number. The moles of KOH is the 0.14, so we can plug that in. 0.14 moles. The mass of the CH3OH, we've calculated that already right here. We calculated it in units of grams. We can convert it into kilograms, 0.4421. 0.4421 kilograms. 0.14 divided by 0.4421 is 0.32 little m. And last but not least, asking us to calculate the molarity of the solution with a little hint, be careful about the volume calculation. So the molarity is going to be the moles of KOH divided by the liters of the entire solution. And we're being warned that the solution volume is not 558.3. We do know the moles of KOH, that's 0.14. So if the volume of the solution is not 558.3 milliliters, then what exactly is it? Well, up here, it's telling us that the density of the whole entire solution is 0.8105, and that's a hint that we should be using this to calculate the overall volume of the solution. At some point, we probably calculated the total mass of the solution. Yes, right here. So right here, we calculated the total mass of the solution. We can use the total mass of the solution and the density of the solution to get the total volume. So I think that what I'm going to do, I'm going to just kind of copy these numbers down. Actually, I'm going to add this up right now to get the total mass. 7.837 plus 442.1. The total mass of this solution is 449.9 grams. I'm going to copy that down here. 449.9 grams of solution. That's our total mass. And we need the volume of solution. So we need our mass to cancel and our to convert into units of milliliters. And that's going to be from the density of the solution. The density is 0.8105 grams. 0.8105 grams for every milliliter. 449.9 divided by 0.8105 is 555 milliliters. In units of liters, 0.555 liters. 0.555 liters. This molarity is 0.25.